All right, foundations of algebra. It's very late, but everybody is sleeping. I'm still awake, and we're going to do the Z puzzle video because I got the time. Graphing linear relationship word problems, which should not be a problem, should be word scenarios because we just did all these problems up there. Writing linear function word scenarios. Recognize functions from tables, recognize functions from graphs. Linear and nonlinear functions, my favorite. All right, well, actually, 3, 4, 5, nice and easy, okay? Well, let's start out with the word scenarios. Okay, so, ooh, Agent Hunt, did not we see him in week 12? Agent Hunt transferred classified files from the CIA mainframe onto his flash drive. The flash drive already had 60 megabytes on it before the transfer. All right, what do we say about that? If you're saying y-intercept, you are correct. We know our y-intercept. And an additional, that's a slope word. Add that to your list. Okay. 4 megabytes were transferred each second. Another slope word. So that 4, definitely the slope. So we got 60 plus 4x. That is our function. And so let's just we gotta stop that microwave. All right, so we have our function, so we know we can start off at 60, which is right there. And now we know every time we go up 1, we would go up 4 because that's the slope. But we can't go over 1. We can only go over 5, 10, 15, 20. That's really not a problem because if the slope is 4 to 1, then that would mean times by 10, we could write an equivalent slope of 40 every 10. And that is helpful. So if the slope is 4 to 1, it would be 40 every 10, multiplying top and bottom by 10. That means when I go over 10, I'm going to go up 40, which is 2 tick marks. So like that. Should work. Look at that. All right, so that's graphing. Now let's do writing. And so let's recap. Identify the slope, identify the y-intercept, use your slope and y-intercept words, which we created last week, and graph it. If you can't graph the slope, then use an equivalent fraction. That's what I had to do. All right, so see how that works for you. Now let's talk about writing. And so we're still going to identify the slope and the y-intercept, or a point. And we're still looking at the units. I feel like we did this already, but let's do it again. Ray is barricading a door to stop a horde of zombies. This could happen. She stacks boxes of books on a table in the front of the door. Each box weighs 30 kilograms. Each is a slope word. Slope? Possibly. I'm writing with my mouse. In the table with 8 boxes on top weighs a total of 310. So I know my y-intercept would be like the table by itself, before any books were put on it at the start. But this is the table with 8 boxes. So that is a point, but it's not the y-intercept. Important to know that the y-intercept is a point, Sometimes we say, is this the y-intercept or a point? But the y-intercept is a point. And this is a point. It's 8, 3, 10, where x represents books, boxes, and 310 and y represents kilograms. All right, now let's see if I got it. The total weight, W, of the barricade is W as a function of x. All right, the number of boxes. which is what I said. Okay, good. So write the function's formula, and it says W equals, which means we can't use point slope form, but we can start with point slope form, which would be y minus y1, which is 310 equals m 30 x minus x1, which is 8. And then we're going to distribute that 30, which would be 30x, with minus 240. And then we're going to add 310 to both sides, use our inverse operations. I know at this point in the year, some people are saying, and use over the line change the sign. But please, even though it's a fun rhyme, people next year are not going to know what you're talking about. So negative 240 plus 310 is going to be 7. And there we go. So let's try 30x plus 70. 30x plus 70. We got it. Okay. So get past those two, which I think you can do. And then these ones are breeds. Okay. So in this unit, we are talking about functions. Okay. So we're doing function word problems, introduction to functions. I showed you function notation. But here we're talking about the definition of the function. So let's write that down. Function definition. And it is a relation is a function if and only if each input corresponds with a unique output. In other words, i.e., no input goes to two or more different outputs. And here a nice story would help drive the point home. Imagine you're going to a vending machine and you press G2 because G2 is Reese's peanut butter cups, my favorite. And you know, the thing about G2, your input is you could get the Reese's peanut butter cups, but G2 also is the same code for spearmint gum. And so you press G2 and you just don't know which output you're going to get. Is that a function? No, because Mr. Field would be upset if he got spearmint gum when he wanted Reese's peanut butter cups, you see? And so that's not a function. That machine is not functioning properly. I don't even like this imaginary scenario anymore. So that what we're going to look at is our inputs, which are right here, and just make sure that each input has its own output. So I like to do that with arrows. Let's just first look and see if any repeat. So boots only appears once, so that's good. Loafers, loafers is here twice. So, it's like two people chose loafers. But look, the output is vanilla both times. So it is a function. The input appears twice, but it goes to the same place both times. Now sandals, on the other hand, sandals being all crazy. One time it goes to banana, but one time it goes to chocolate. And so for this reason, big X, not a function. That's what I mean by that. I mean to say that this is not a function because sandals is an input that is going to two different non-unique outputs. No. Moving on. Okay. So go ahead and pick out your functions and non-function. We can also do this. So that was from a table, and they could be words, they could be numbers, same process. Okay, and now with the graphs, it's still the same definition. The inputs are right here on the x-axis. Inputs, The outputs are the y values, okay? But we like to use something called a vertical line test. It's a nice, easy way to see if a graph is a function. And I should have said, I said relation in the definition of a function in the last problem. So a relation is any collection of ordered pairs or x and y values. A circle is a relation, but not a function. So a function passes the vertical line test, and that is if one were to pass a vertical line through every point on a function, that line only intersect the function at one point. That is the most verbose definition of the vertical line test I've ever made, but I enjoyed writing it. Hope you enjoy reading it. Let's use the vertical line test. So I have this vertical line here, and I'm gonna take and pass it through. And you see it only intersects the blue line at one point, no matter where I put it. So yes, that's a function. Let's see what the next one. So let's pass the vertical line through this guy. Still, it only intersects at one point each time. So yes, again. I'm gonna go till I get up. Now here you go. Here you go. Look at this one. Every point just about is in violation of the vertical line test. I'll just take this one right here. You can see boom, passes, intersects there and there. This is our first example of a non-function. All right, last one. So I think I might have answered this one too. Could the table XY pairs have been generated by a linear function? So I just use the same -2, 1, 4, 6. Yes, all those inputs are different. Oh, whoopsie daisy. -2, 1, 4, 6. So why, you know what I should have done? I should have graphed it. I was too quick. I saw the inputs and they were all different outputs. So I said, it's still kind of thinking. So let me graph it to see where I went wrong just now. Because I'm not re-recording this video. All right, we're gonna find our mistake. 4, 3, 2, 3, 4, 1, 2, 3. So everything's looking fine. 6, 5. Okay, so all right, so I figured it out now. It could have been generated by a function, but you see the curve here? It could not have been generated by a linear function. Come on, Mr. Field. Read the whole question. Okay, so I guess now we're talking about linear. So linear is a line, straight line. Oh, and it says linear and non-linear. Come on. So a linear function is a line, and this is not a line. And so see if it's a line or not. That's all you got to do. Okay, and get one wrong, don't even worry about it. Just put it in the organizer, find a mistake. You're gonna do great. And that is all she wrote. All right. So after this, we're going on to geometry. It's gonna be a blast. We're gonna do that after break, but make sure to get all these done before you go on vacation, and you will be in good shape. All right. See you in class.